All right, good morning, everyone. Let's get started with today's exercise. So today we're going to start working with satellite imagery. And the first step of that is to download that imagery to our computer so we have access to it. Um, I did just push to GitHub a new script for today. So I want you to go get that script. And then I ask you to, on the main folder of the course, you create this project called 14 Satellites. Under that project, you want to have the usual setup of code, data, and output folders. Create your RStudio project at that level, and then move the code into the code folder. I have a few other files here on my code folder that you don't, but you're going to want to see something like similar to this, where your main folder is 14 satellite. You have in the code folder the partial script for today, and then the data and the output as well. And then finally creating that RStudio project there. I'll give you a moment here for you to catch up and do that, and then we'll get going. All right, so I'm gonna start moving here. If by the time that we get coding, you still need more time to finish this, let me know. So assuming that you're able to get to the same place that you're seeing here on my screen, let's go ahead and launch that 14 satellite R proj. And you can go ahead and launch your PowerShell script on your side. All right, so before we get to coding, let me lay some introduction here, some background so we know what we're doing. So today's goals are going to be for us to understand the different options of data we can pull from Planet. There's going to be a lot of different options, and it's going to be important for us to identify what those are and what's the best for our condition and situation. Then after identifying that, we're going to define those parameters of interest to pull imagery for our site. And then lastly, we're going to make an API call from R and download that imagery directly from Planet into our computers. Okay, so if you have not heard of Planet, Planet is a private company that offers satellite-based imaging products. Planet is really disruptive in remote sensing, especially when it comes, well, for us, especially when it comes to agriculture. The reason for that is up until before Planet was launched and started as a company, we had this huge trade-off in satellite imagery between temporal and spatial resolution. We talked a little bit about this in a previous lecture when we're talking about the variable rate nitrogen lecture. But basically, temporal resolution of a satellite is how frequently it flies over the field, right? So how long does it take to revisit the same field? Spatial resolution is the pixel size. So how large is that pixel? Up until Planet was launched, there was this trade-off. So satellites that had a very frequent revisit, so let's say every day you would fly over your field, had a very coarse pixel size of like 1 kilometer. On the other hand, satellites that had a more frequent revisit time, or I'm sorry, a less frequent revisit time, so let's say every 15 days, had a coarser pixel, or I'm thinking in two things at the same time. So let me take a step back and repeat that. Satellites that come very often have a coarse pixel size. Satellites that come less often have a smaller pixel size. So, one example here is AVHRR. I think that's the acronym for it. Is one satellite from the U.S. government that comes at every day, if I get that right. But it has a very coarse pixel size of 1 kilometer by 1 kilometer. So you get a lot of data in time, but in space it's very coarse. So you cannot really see much. On the other hand, we have Landsat. Landsat is a very popular satellite mission, also from the US government, that comes at every 15 or 16 days, but it has a pixel size of 30 meters. So you can see more, but it comes less frequently. One issue with satellite is whenever it flies over a field, if there are clouds covering your field, you get no data. So imagine you're relying on Landsat, and then it comes every maybe a couple of times a month, and it's a key stage of the growing season. You need that imagery, and it comes around and it has clouds. So you're only gonna potentially get a new image in another 2 weeks. So, and still, we still have the potential issue of then getting clouds on that next revisit. So clouds are a big problem here, and satellites that don't come as often is even more problematic, because if you miss that time, it may take a long time for you to be able to get imagery. So Planet came into this position here, and they really disrupted, because the products that we're going to be working with, we can get daily imagery, so very frequent revisit time, at 3 meter spatial resolution, very small pixel size. So that's why Planet came into this space and addressed both limitations of that trade-off between temporal and spatial resolution into one product, or many products, but the one that we're going to be using is going to be one product. Just so you have some idea, Planet, we're going to be using today data from a overall constellation called PlanetScope. That's daily revisit time, 3 meter spatial resolution. But Planet has some options that they can actually image the same field over 10 times in a day, if needed. Of course, those products are more expensive. We don't have free access to those products. But if, let's say if you're a government that you want to be taking multiple images over one area because of, I don't know, military reasons, whatever that may be, Planet offers that. So they're really disruptive, not just in agriculture, but across uses of remote sensing data. So yeah, we're going to be using Planet data. The way that Planet refers to their satellites, they're referred to them as doves. They're very small satellites, and they deploy many of them. So there are many dove satellites flying. They have 3 main missions here that's going to be important for us to understand what data can we use for what field for when. So the 3 main flocks that they have, the first one was called Dove Classic, and the acronym for that is PS2. These acronyms are going to come back in the script, so you don't have to remember them, but keep in mind what they mean. Dove R was the second flock that they released. It's called PS2ST. And then finally, Super Dove is the third flock they released. It's the newest, most modern, the best data we can get would be from this constellation here. Each one of these flocks have specific available bands. So remember, we talked about bands in the visible range and the near infrared range and other ranges of the electromagnetic spectrum. They also have different temporal coverage. Now, I want to make a distinction here. Temporal resolution is how many days it takes for it to revisit the same site. Temporal coverage is when did that mission start and when did that mission end, right? So this is going to be related to when can you get data from the past. So another thing I guess I didn't mention here, but the beauty of satellite data is that there is an archive, right? So that means that if you want, oh, I have this field here that I want to check the data for 2018, you have that. I mean, potentially you have that depending on the sensor. But you do have an archive that you can go back in time and look at data from a field, even if at that point in time you didn't think you needed, but now you think you do. So that archive is also really important for us here. I left you a link for us to explore those bands. I want to open that link quickly here, just so we check some of the documentation from their website. So the PSP-SD, just to make sure that is the latest one, that's the Super Dove. It has 8 bands, and here are their names. Here are the wavelengths. This could be important for you, especially for doing research, to be aware not just of the name of the band name, but actually its wavelength and the full width at half. I don't remember what the M is, but this is pretty much the width of the band. So remember that the electromagnetic spectrum is a continuum that we kind of chop it up into pieces and give names to those pieces, right? So like in this case here, the wavelength of 490 nanometers into a 50 nanometer width is what they're calling blue. But remember that different sensors are going to be calling the center of that band, and also the width of it may be a little bit different from sensor to sensor, even if they call it the same name. So blue band. So the latest constellation has all these 8 bands here. So they're starting the first table was for the Super Dove, which is the latest one. The second table I'm going to show you here is for the Dove R, which is the second constellation they released. And the latest one here, or the last one, is for the oldest constellation, PS2, the Dove Classic. So they have these differences, which bands are available in which sensors. The first 2 flocks, so Dove Classic and Dove R, only have 4 bands, which are blue, green, red, and infrared. The latest flock, the Super Dove, has 8 bands. So there's going to be a difference in what the number of bands and which bands are available depending on the constellation. All right, coming back here. Another important concept here is within each one of those constellations, we have different asset types. What does that mean? An asset type is basically what type of data from that constellation you can have access to. And different asset types have been through different levels of processing, which is going to be very key for us to understand. So there are 4 main types of assets, ranging from basic analytic, which is the least processed, going to analytic, visual, and surface reflectance, which is the most processed. It is what we want to use. Unless you're taking another course on a purely remote sensing, satellite remote sensing class that teaches you how to hand analyze, or not hand, but for you to analyze a very little processed product, which, some people, if you're in geography or maybe other field that is very remote sensing focused, you may go through a class that teaches you how to take this layer, basic analytic, and process yourself until you get to surface reflectance. That is not what I'm going to be doing in this class. I'm not teaching you how to process a very raw image into what we want. I will show you, because what we want, surface reflectance, is an asset type. Asset type is a product that is available to us. So if it is available to us, we might as well just make use of that rather than having to go through all the processing ourselves, which would be very intensive. So we want surface reflectance. Another comparison I want to make here is for all of these satellite products, these imagery products, you may see on their documentation, maybe on the literature, this difference between top of atmosphere reflectance, or TOA reflectance, versus surface reflectance. top of atmosphere reflectance is basically the reflectance signal at, as it says, at the top of the atmosphere. So it has no corrections for the atmospheric influences on that signal. So it is a somewhat raw type of imagery product that some people use it without further processing, but really top of atmosphere is unprocessed in relation to atmospheric corrections. Surface reflectance would be, as the name says, the reflectance from the surface of the Earth. So whatever is below the atmosphere. So the surface reflectance has already been through the atmospheric corrections for us. And again, in our case, we are not the ones doing that correction. It's already, we're just pulling a NASA type, a data type that has already been corrected for us. I leave you here as well another link for a different page on Planet's website that you can also explore, where they explain in more detail the different constellations, the different names, some of these imagery products, and asset types. So if you want to know more specifically what each asset type is actually, how that is processed, you can just further read this documentation. And this is just the image process chain that Planet has. So satellite collects data, comes in as raw data. It goes through sensor and radiometric calibration. This is all happening on the site of Planet, right? So it's not something we're doing. They register it on space, and they release a basic scene product. Remember, this is the least processed product that we get access to. Then they do orthorectification, which is just removing terrain distortions, create an imagery, and then release the other products, where the one that we want is the surface reflectance. This, for us, as far as I would always recommend you get surface reflectance. But then you may think, well, why don't they just make that available to everyone? Why do they provide these least or less processed products before getting to surface reflectance? At least to my understanding, the main reason there is because they can make this product available within, I don't know, an hour of the satellite actually collecting the data. So the data availability is a lot faster if you get a least process layer. However, even if you're going for the most process, which is what we want, the time from imagery collection from the satellite until you have access to surface reflectance is less than a day. I think it's like 8 to 12 hours. So it's not like you're waiting a month to get the process imagery. It's still within the data that's collected. So for our purposes, I don't think we need to really worry about the other products and really just focus on surface reflectance. Let's see what was here. Okay, awesome. So Planet is collecting all this data, like so much data every single day, like across the whole world. Many satellites, many doves are flying, collecting data and uploading that to Planet's Planet servers, where they get processed. And once they reach different levels of processing, they're made available on Planet's database. We could, if we wanted, go manually, so point and click, go into that database, make a drawing of where our boundary is, define our filtering options, and do that manually. We could do that. However, I want to show you how you can do that in a programming way. So it's easier, it's reproducible. You don't have to be going to your browser and opening things. And so it's all going to be in this script here. So that's what we're going to do next. All right, so a couple things here. We're going to be using some packages that some of them we, at least in this class, have not used. Others, you may have installed that as a dependency of a different package that we already have. And if that's the case, then you're going to have to install today. So the package in R that we're going to be connecting to Planet's database is called PlanetR. This package here is not on CRAN. which means that if you do an install.packages planet R, you're not going to find it. You have to install it directly from the source code, which is on GitHub. Whenever we install a package from GitHub, we need to use another package that we do install through Plan, which in this case here is called remotes. I think we have used this package before. So we're going to use a function called install GitHub from the package remotes. If you run this and it says you don't have package remotes, you're just going to have to install it. So just do an install.packages remotes and then run this line of code. So that would install for you the package Planet R. And then we have three other packages here: HTTR, JSON Light, and BeepR or Beeper. So make sure you install all of those packages. Once you have them installed, you can just load the whole chunk so we have access to the functions from each of those packages. For me, here's just giving me some extra information, but there's no, when I load the packages, it just gives me this message, but that is not an error, so we don't have to worry about it.
Is the GitHub one supposed to take a while to download?
I don't remember. It's been a while since I installed. Is everyone else having, like, waiting for that to install?
Yeah, yes.
Yeah, it's just like here in Tipton, it's taking a long time to install.
Yeah.
And it didn't. Okay. Huh. Yeah, I don't recall. Is it given any warnings or errors, or is it just
Wait.
Oh, okay, okay. So, I think I can do on my side as well. I can just reinstall mine and go through that. So if we run
Mine's saying like I can enter numbers or empty line to skip updates.
Okay, so I think what's going on there is as you're installing this, this package probably has some other package dependencies that can be updated. So if you don't answer on the console that you want to install all of them or none of them, then it's not that it's taking long to install, it's just waiting for you to answer so it keeps going. So if on the, well, let me see here, which one I can see your computer.
Okay, so I see where it gives me option 1, all, 2, and 3, none.
Yeah, so if you just type 1, yeah. So just go ahead and type 1 on your console. So you say you want to update all the packages, and then that should get through. After you push 1, did that install pretty quickly?
Yeah.
Okay, yeah. Yeah, so yeah. It's not that it was like a heavy package to install. It was just that it was waiting for you to say what you wanted to do about installing updates or not. All right, so I'm just going to give you here a moment to install the packages, and then we'll get going.
Dr. Bastos?
Yes.
I get an error on install package JSON Light.
What is it telling you?
It says error unexpected.
You got this
on-
the JSON line.
Sorry, Rolando, can you repeat that? What was it? What is the error?
The error said unexpected on end of quotation and in quotation like a regular quotations.
Did anyone else have issues with JSON Light? So what I think could be happening is, so look on your console. So because my hypothesis is that maybe when you were trying to install the first package, maybe that didn't finish going through, and then it's still working on that, and then you're trying to run something else before that finishes. So what I would say is look on your console. If you're seeing like the greater than symbol and a blinking cursor, it means your console is in idle. So it's ready for the next thing. If you don't see this greater than and your cursor blinking, it means your cursor is, or your console is busy, is doing something, which could be related to this hypothesis I have. If your console is busy, there's probably going to be a stop sign here, which is not on my side because it's not running. But if yours, you see a stop sign, click on that stop and it's going to abort whatever is running, and then try again.
Okay. I think it installed it already.
Okay, nice.
So let me just rerun it and run all the library.
Awesome. Yeah, and I think well, let me know how that goes. If you still have issues by the time that we get. If we're running code and you cannot run, then let me know because it may be related to that.
Yeah.
All right, so let's continue here. Go ahead and run the chunk so you load all the packages. And we're gonna start to get things ready for pulling data from Planet servers. So for us to pull satellite images from the Planet API, we're gonna need to define a list of parameters. Some of them are site field specific, some of them are sensor or satellite specific. So let's talk about both types of parameters here. So the first one, we need to define a field boundary bounding box. We need to give the function a spatial bounding box of where I want images from, right? This is going to be important because, of course, you don't want to get, so the way that these satellite images are made available are as tiles, which is, I don't know what is the size of a tile, but it's way larger than a single field. You don't want to pull imagery for a whole region if you don't have to, right? So we need to give the field bounding box. So we define that spatial extents that we're interested in. We need to define our start and end date as well. We have to say, well, I want all potential imagery from this date to that date. In our case, our interests are crops. So I want to pull imagery during the growing season. And I'm just arbitrarily defining growing season as from April 15th through September 30th. You can change those dates if you have different crops, if you have different growing seasons, it's going to be up to you. For our case here, that's how I'm defining that. And then I want to do that for 3 years. So the 3 years that we've been working on this field that we have yield data for, so 2017, 2019, and 2020. We need to tell the algorithm how much clouds are we willing to accept into the imagery. Imagine that if you have an imagery completely covered by clouds, it's going to be of no use for you. So but however, if you have just like a piece of it, maybe a corner, maybe right in the middle, you have a little bit of cloud coverage, you can tell the algorithm to still give you that image because you would still be accepting that. So we need to determine how many cloud percentage we are willing to accept. Then we're gonna need the item name, which is related to the constellation that we want to pull from. So the 3 that we talked about in the beginning, and then what asset do we want to pull from that constellation, which again is going to be the type of product that depends on level of processing. So let's start defining these parameters right below here. If you come to the next chunk, we're going to define our bounding box. So if you remember the concept of a bounding box for any geospatial file, a bounding box is basically the outermost, like if you were to take the eastmost, westmost, northmost, southmost point within the shape, that rectangle is your bounding box. So let's get the bounding box for the field that we've been working with in this class. So for that, the first thing we have to do is bring in the boundary, right? So let's give here a read SF. We're going to navigate to where the boundary is. If you remember, we have to get outside of the code folder, get outside of this project, navigate to the 05 digitizing project, go into the output folder and pull our boundary.geojson. That's where the boundary lives in our in our case here. If you run that, this is not a bounding box yet. This is the actual shapefile of the field boundary. To get the bounding box, we're gonna give it a pipe and use a function called extend. So this function is coming from the raster package, but it is gonna give us the bounding box in the format that the planet function requires. So if we do that and we print it, we get an object of class extent that gives us the x mean, x max, y mean, y max. All right. Another thing I want to do here is give this site a name. That's going to be important when we're downloading imagery and we want to keep things organized. So this, if it is a research, it could be 2024 Watkinsville, Midville, Tifton, whatever it is. If this is a production site, you can give whatever the name of that field is. In our case, it's going to be our class site, which we analyze data for cotton. So I just want to call this class cotton. If you run this, it's really just a very simple object that has a name, right? Or that has a string that contains the site name. Very simple. All right, the next step here is going to be to create objects that are going to hold the dates that we want to have, both the starting date and the end date. So the way that we're going to do this is using a function that is called s.date with uppercase D.
Hey, Dr. Bastos,
Yes.
question, could you scroll back up just one more, just a moment to the extent? Okay. All right, thank you.
No worries. All right, so to define the start date, we have to create a date object. So for that, we use the s.date function. Inside of that function, if you open and close quotation marks, we're going to give a full date with year, month, and day. As I was telling you, let's begin pulling data for the 2017 growing season. So 2017 is the year, and then we define growing season going from April 15th. So this would be the start date. So if you run that and you print that object date start, is just a date. Very simple. We're going to do the same thing with date end. So we call the function as dates, open and close quotation marks, and we're going to give it 2017 09/30. So September 30th is going to be the end of the growing season as we are determining it. Make sure you run that so you have that object created and you can print it to inspect it. All right, so these are some parameters related to your field, to the growing season, so nothing really sensor specific. Now we're going to get into the sensor parameters. The first one that we're going to change here is going to be the cloud limit. So I am willing to accept 20% of clouds in my image and still take it in. This number here is perhaps arbitrary. If you are doing something that you have to see the whole field every time, then you may say 0 for cloud limit, which means that, let's say that in the end you get 100 images. And those 100 images, maybe you have a completely cloud-free, maybe 10, right? So the smaller is this number, the more restrictive you're being on how many images you're taking in. Of course, if it's 100% clouds, then it's of no use, right? But there is a limit that you can play around with this number and be more flexible or more rigid as far as how much you're accepting of clouds in a given image from a given date. All right. The next thing that will change is our item name, which is going to be the PS scene, which is going to give us that data from one of those 3 constellations. The different options we have here also include Landsat, Sentinel. So there are other types of constellations or satellites that we can pull data from through this API. But for us to pull the one with the highest spatial and temporal resolution, which is PlanetScope, then we need to say PS scene to get PlanetScope data. which again is at daily spatial temporal resolution with 3 meters spatial resolution. As we talked about, even within this item name, even within PlanetScope, we have 3 different constellations that we just talked about, where some of them have 4, another one has 8 bands, and we want surface reflectance as well as that product. So talking specifically now about our choice of getting PlanetScope data through PSC. So when it comes to bands, sensor PS2 and PS2ST, which are the first and second missions, they only have 4 bands. Those are red, green, blue, and infrared. And then the latest one, the Super Dove, has 8 bands. So on top of those 4 initial, also has another green, a yellow, coastal blue, and a red edge. So just thinking about this, you would think, well, let's just go for the one that has 8 bands, right? That's going to be the best one. It gives us more data. The limitation there is the temporal extent, and this is important for our case here especially. So the PS2 imagery, which was the first option, the Dove Classic, it has imagery available from July of 2014 to April 2022. If we want to pull data from a site in 2017, it has to be from this source, which means we'll only have 4 bands. We do not have option of 8 bands if we want to pull data from 2017. The second constellation goes from March 2019 to April 2022. And then the best constellation we have available, the Super Dove, is available from mid-March 2020 to current monitoring. So in activity today, the Super Dove is the only constellation still active. But nonetheless, the other constellations collected data in the past, and that data is still available for us to pull from the archive. So in our case here, for this site, if we want to pull data from 2017, we have to go with the PS2 option, which again only has 4 bands. All right, so let's turn this text into code in the chunk below. So we determine all those parameters there. So cloud lim is that cloud limit. It's going to be a number between 0 and 1. If we are accepting up to 20%, that has to be equal to 0.2. Make sure you run that so you create that object. Our item name is going to be PS scene with PSS uppercase. The way that you would find other options that you can explore here if you wish is going on this website that I'm linking below. If you go there, you want to quickly explore that. It's going to have here an explanation of the different item types. So in our case, item type is the PS scene for PlanetScope. There are other item types we could use here, including Landsat and Sentinel as well, just for a reference. If you, let's see here. If you click on the name here of the item type, which again, for us is PS scene, it's going to give you more information about that specific item type, including the different assets. So let me get to that here. So the available assets, this is a list of available assets. And again, remember that assets are different types of processing levels. We want the one, any of these here that have SR, which stands for surface reflectance. We see here there is an orthoanalytic 8B SR, which is the one that has 8 bands. There is a orthoanalytic 4B SR, and that's all. So in our case, we are going to have to ask for the 4B SR, because if we ask for 8B SR, it's not going to, and we give the dates, it's going to look at the algorithm when we submit the call, it's going to look at the dates, see that we're asking for 2017, and it's going to tell, and it's not going to tell you clearly in the error message, it's going to say it's not available. But we know that we do not have A-band surface reflectance data in 2017, that only started in 2022. So we're going to have to ask for the 4 bands surface reflectance option. Right, coming back to our script here. So the asset is going to be that name. Sorry, I'm going to go back to the website. It's going to be this name here, orthoanalytic 4B SR. I'm just copying that. If you want to type it out, you can as well. But make sure you type it correctly if you are typing. So ortho underscore analytic underscore 4B underscore SR. And then make sure you run this chunk so we have those values saved into those objects. Okay, so if you think that there is potential for you to get one image, sometimes even more than one image per day, and we're asking here for 5 months worth of data, that's going to be potentially a lot of images. So we want to create a folder structure that helps us to organize all those files. So I basically left you here the code, but I just want to include in the folder name, what is the site name, what is the item name, the asset, starting date, and end date. I left you here a code that basically takes all those objects that we created, extracts different information from the dates, and just paste that all together into using the paste function, and then separates each one of these pieces with a dash. If you just run this, you don't have to code anything, just run it. So this is going to be how the folder is going to be called. Class Cotton, PSCene, Orthoanalytic for BSR, 2017, and then 105 is the start date as day of the year. And then 2017 to 73 day is the day of the year as well of our end date. So this is going to be how our folder is going to be called. Now, you can help me to code here. We're going to create this folder. So we're going to use a function called dir.create, which is a function from base R to create a new folder. We're going to use another function inside here called file.path, also from base R. Open and close quotation marks. I want to navigate to the data folder. So .. to get outside of code. And then you can hit tab and select data. Right after this quotation mark, you just add a comma, and we're going to give it the name of the object that we created above. So export folder is the name of that object. And if we come outside of the first parenthesis here, we want to change an argument called show warnings and set that to false, uppercase F. So if you run this, the only thing that this code does is if you go now to your data folder, you should, well, I have a few ones here from different tests. Let me delete those and rerun from my side. It's basically just creating that directory for you. And we're going to ask for, whenever we're downloading Planet data, we'll ask for all those images to be saved into that folder. This here is important, as if you're going to use this script for a different project or a different field altogether, you do want to make sure that you update your site name. And then, I mean, your dates, you always have to be thinking about them, right? So this, I'm sure you're going to be thinking about your dates for different projects, but change your site name as well, as that's going to help you to keep your files organized. And you don't write, something into a Class Cotton site that you've named. All right, so the last thing here on this script is going to be to, or sorry, not the last thing, but the last thing on the processing side of the script is going to be to tell your API key. I know some of you may have issues. If you have issues getting your API key or even logging in to the website, let me know. But this key is going to be specifically to each one of us, right? So we should not really share keys. And the main reason is that each one of us has a set quota of how much imagery you can pull. So if we all share the same key, we're all going to go over that monthly quota very fast. So make sure you do have your own key and you know how to get it. Before I take a moment and ask about if you're able to get your key, I just want to tell here. So you're going to come here and basically give the assignment symbol on this chunk, open and close quotation marks, and whatever was your key, you paste that here. It's okay on your script if you want to paste your key in your script, as long as you're not sharing your script with anyone else. In my case, I save my key into a different file that I'm just gonna call that file here.
Do you have the key? We gotta find the key. I don't remember.
I'm assuming our email.
So to get the key, so you had to first sign up for a research program account with Planet. We did that in class in one of the, I don't know, maybe a month ago. Once you signed up, then Planet would reach out back to you saying that your account was accepted and that you could log in and create an account. Once you log in into Planet's website, on your, you're gonna have like, you know, my account. If you go on the top right, there's gonna be your name there. You click there, there's gonna be an option for my account. And on one of those options is gonna give you an API key. I don't fully remember the path here, but I guess I can show you on my side. So if I come on Planet, you can log in. Yeah, so here's my account. If I come, maybe my settings, thank you. So my settings here is gonna have your API key. You can just clicking on that copy API key and just paste that straight into R. If you are having issues, I mean, if you are not able to get an account, or maybe if you're not able to log into your account, let me know. I can help you to troubleshoot that. My goal is that you do get your API key, but if by the next class period, if you don't have your API key, then I'm just gonna give you the imagery myself. But my goal is that you have it so you learn how to do it yourself. No, you don't have to do the source. That was just on my side, so I didn't show you my API key here when I created it. This I can show you later. Yeah, I just want to make sure we run here on the we finish the script before this class is done. Yeah, so you would just have this here. You just have your API key pasted right there. Okay, so now we have all the different pieces we needed to make our API call. Don't run this yet because I want to tell you a couple things. So this is the function we're going to use, Planet Order, which comes from the Planet R package. All of our settings that we define, the parameters we define are here.
Yeah.
I'm not going to go through each one.
No.
Do you have your account?
I mean, I got the emails, but I don't even see how to log in.
So I guess if you're having issues with key or logging in, don't worry, because I want to show you here something that's going to be important and we're not going to finish in this class. So I just want to show you here so we can try, you know, before our next class period. Once we run this function, is going to make a call to the Planet server API and ask for images that match these parameters. When I've done this in the past, and I was able to download imagery for a given field, I don't know, within 10 minutes of waiting on the queue, because there is a queue once you make the API call. I tried doing this last night and this morning, and I was just in the queue for a long time. I was able to connect with the API, but I was just waiting in queue without successfully being able to download the imagery, because I was waiting in queue and I didn't let it run enough for me to be the next person and be able to get the data itself. So I'm saying that because once you run this, it may place you on queue and you may be waiting for a while, and I don't know for how long that could be. But because it's a process that the download itself doesn't take long, but because you are in queue, that may take long. I'm giving you here a trick for you to play. Don't do it yet, but when you play this chunk, you can, you know, if you're working on something else, you just, you know, minimize RStudio and go do whatever else you're doing and just leave this running behind the scenes. And whenever it finishes running the chunk, which means that you're able to download the imagery, this piece of code here is going to make a beep, a sound for you. So it's going to give you a sound letting you know the chunk finished running, meaning that your place in the queue was there and you were able to finish running the chunk. So if you just run that again, there's just going to be a sound. Make sure your sound is up so you can hear it. And then if you're able to set up your key and have that above, you should be able to run this. It's going to give you some information here. So it's saying that it's searching for my day of the year and the year ranges. It found 47 images for that growing season for me. I have an order ID, and then it's saying that it's placing me in the queue. And every 60 seconds is going to give you an update if you're still in the queue, if you're still waiting or not. When it gets to your place in the queue, it's going to download that to the folder. So again, if you make sure you run the chunk, it's going to give you that beep once it finishes running, so you don't have to be watching our studio. You just have your sound on, and that's going to do it. So I do want to ask you all, including myself, because I don't have imagery for this field for 2017, to try this. I don't know how long it's going to take for you to be the next one in queue, but my hope is that we can get this downloaded for our next class period so we can work on this. I'm going to be trying this today through the weekend. So order is still being processed, trying again 60 seconds. So I'm still in queue. I will try to get this imagery for us to work on the next class with imagery that we pulled. If for some reason Planet servers are having some problem that none of us can download this imagery, I have a plan B. But for now, plan A is to pull this imagery for this field, for this date, and have it downloaded before our next class period. All right. I want to get your attendance. Yes, you have to have your API key defined. Let me get your attendance, and then if you do need to leave, you're welcome to, and we can spend another couple minutes troubleshooting anything that you have. All right, so just open an issue for attendance. Make sure you claim your attendance, and if you don't have any questions, you're dismissed. And if you have questions, I'll hang around for a moment here to help anyone. All right, any questions? If anyone needs help figuring out their API keys, how to get in, let me know. I can help you there.
So I guess it will vary the time. It can take hours.
So yeah, I guess I don't know how long it can take. It's just going to be whenever it gets to your place in the queue. Yeah, my previous experience with this was pretty fast. I could get to my place in the queue within like 5 to 10 minutes. In our case, I don't know. Yeah.
See the directory.
So you mean, wait, this one here? The dir create.
Because I already downloaded the data, but it went to my phone.
Oh, you already downloaded for you? Cool.
This is
Okay, nice. Was anyone else able to download? Okay. Nice. Well, I can help you with that. I guess, let's see. Okay, Gonzalo also got them. Okay, now it's going for me. Yeah, I guess you can see that. So it's like downloading. Yeah. So I guess, yeah, it didn't take a lot of time. So that's a good thing, but. All right. Well, I can help you with that. Well, I guess we can wrap up for today, but if anyone has issues or questions, let me know. Again, I do want us all to have these images downloaded before our next class, because we're going to be processing them. So make sure that happens. If you cannot, for some reason, let me know and I can share the ones from my side with whoever cannot download. Yeah, just 2017 for this script. Yeah. All right. Thanks, everyone. See you on Monday.